record. Then we get the stream up. Ooh, that stream is bad right now. Oh, okay, there it goes.
There was like 4 people down there, so it looks like Tony will be the one.
From our class?
Yeah.
Oh man, we need one more. I'm hoping for one more. Streamers, let me know if the stream is bad. It should be up. We're gonna get started in just a moment. That doesn't happen. It could be one of you.
10?
I guess if it was one of you, I might be like, meh.
Let's go to the bar.
Yeah, we'll figure it out.
It's crazy. So it counts against you if people are streaming?
Not me. Counts against you, because you can only stream so much before they're mad at you.
You were worried about numbers.
Oh no, I'm just doing an over under on how many people are streaming today.
Oh, okay.
It's a bet thing.
Yeah, it's more of a bad thing.
Yeah, it's not a. Yeah, I'm trying to make this more exciting for everyone. Well, for me, but what can you do? Stream looks good, says Charlie. Charlie, thanks, but I was hoping that was a message saying I'm streaming too from someone else. So you ruined my over under. Okay. So we are gonna start with a warm up. We have a really long, like a ton of activities today. We don't have to finish them all. The only thing that's critical is at the end of class, there's a checkpoint that we're gonna give. So you got to take that. You'll have like 30 minutes to do it at the end of class. So we'll select it out right at the very, very end, probably like 9:20 or so. Otherwise, we've got a ton of stuff to cover. We're pretty much going to be reviewing the whole Handlebars Express node stuff, but we're going to be adding something in as well. We're going to be talking a little bit about ORMs today and what those are, what that stands for, and before we jump into them, head first next week, or Saturday, I guess. Oh man, next week's going to suck. I'm just warning you. It's not going to be a fun week. Okay, so let's go ahead and look at activity 11. I am going to go to the solved. I'll make sure I run these. Alright, npm install. Whoops. So I got to run npm install. Then I got to MySQL. Carson. Password equals admin. Alright, so there's 2 SQL files, schema SQL, which this little syntax right here from the command line is letting me automatically run that SQL syntax, that SQL file. Insert into... You don't think my password's secure?
No, it's so insecure.
Cat. Yeah, it really didn't like that. Quotes DB, okay. So now we're gonna do it again. Yeah, I don't care what MySQL thinks. We've had our problems. Quotes DB, I think is what it was. We'll run seed SQL. Okay, so I should have everything in there. Node server.js. Nope, I did something wrong. Oh, it's probably my... You gotta be kidding me. If I get that error again after I change this connection information, I'm gonna have a shit fit. Like MySQL and I, we got a problem. Alright, let me fill this out. My super secure credentials. Make sure this works. Hoo-hoo. Oh. No way. That can't be right. Oh, that was the unsolved I just changed. Boom. Look at that. It's easy to make mistakes, guys. Could I have prepped this before class started? Yes. Did I? No.
Too busy betting.
Yeah, I was too busy betting on you streamers. Alright, okay, we're connected. Woo, we did it. Alright, we have this bad boy, Quotes app, that you're going to be making. Again, it's going to have the MySQL, the Express, the handlebars, and all that fun stuff. You'll be able to delete quotes. You'll be able to update a quote. I love chili. Teddy Roosevelt said, I love chili. one point in time. You can see that they are persisting. Abraham Lincoln. You miss 100% of the shots you don't take. I think Abraham Lincoln said that. Boom. Anyway, we have a list of quotes. You can update the quotes, delete the quotes. You can add a new quote. Simple CRUD app, right? MySQL, Express, handlebars, all that fun stuff. This is what you're going to be building. Go. This is number 11, quotes app. This bad boy right here. Ooh. There's a trick to this one that actually isn't here in the directions, doesn't look like. But there are static files in that public folder. There's some JavaScript and CSS. You also need to figure out how to serve those. And you should be able to just Google serve static files with Express to kind of help you find that.
Running like all at the same time. My room is like really like can use one of the whole house at all times.
Give you about 5 more minutes to work on this one.
Okay, cool.
I don't know what that means. You done already?
No. I found out what an error meant.
Oh, good.
I was like, why is my local not working?
Shit happens.
No, I can't think about it. I did two different ones. All right, let's go over this. So this isn't too different from the stuff we did on Monday. Just kind of rehashing all of that.
with the handlebars, get you guys warmed back up. Did anyone figure out how to get that static content served, the JS and the CSS files? Anyone figure that out? Yeah, Andy?
It's already kind of like in handlebars.
It's not in handlebars, but it's in Express.
It sounds like there's a route in handlebars.
You can do it. There are, so remember handlebar serves HTML, right?
Right.
So your view main layout will have them referenced as script and link, just like we would do with any old HTML file. But in Express, you can use this app.use express.static and give it the name of the directory you want to be static, aka static content. Doesn't change, doesn't need to be affected by handlebars, it is just served. And in this case, we called the directory public, and right here we have a public directory that is in the same root as our server.js file. That's what's important right here. See, we have public here, server.js. And what that does is tells Express when we're looking for anything that would be in the public folder, for instance, if we referenced it by this assets, it'll look there. If it finds it, great, we'll send it. Otherwise, we'll go through our routes. And since in the main handlebars we're referencing those with the /assets, it's going to know that those are in that public folder, that static content, and it can just find them. So the reality is when you have JavaScript files, CSS files, and you're just serving that static content, it's literally just a file in the file system that your application knows to just go pull and send it back to the browser. That's it. That's all it is. Just like when we were doing the read file stuff with your HTML, and we were just pulling the text and sending it back up in the res.send or whatever, it's just like that. It's telling Express, just go find this content, read file, res.send this content out. And we're good to go. The browser will figure out how to render it as CSS or render it as JavaScript or whatever, right? Any questions on how static content works? Notice, too, that the Express static is before any of the other middleware. It's before the encoding middleware. It's before the JSON middleware. It's before our routes. The reason for that is it bypasses all those things, right? We don't need to worry about doing JSON parsing or form parsing for static content. It's literally static content. We don't need to worry about our routes for static content because it's static content. It's just coming out of the file system. So it comes first. The only reason why you might want to put it after a middleware is if you really wanted to authenticate that path. Maybe you have a middleware that checks for credentials or something before it grabs that content. But usually with this kind of stuff, that's not very common. There might be other types of resources that you do that with, and you do it through traditional route. Anyway, what did we have to do? Well, we had to have the ability to list all of our quotes. So just like Monday, we can have a route, a get route that's just at the root path, right? And that's going to execute a query with the database that just gets all of the quotes. Nothing fancy there. Pulls back the data and injects it into handlebars, into our index.html, or index.handlebars layout, right? Any questions on that one? That's probably the straightforward route in this whole thing, right? So then we want to be able to get the individual quote. So to do that, we have a parameter specifier, that :id, saying we're going to get the quote by ID. So then we'll run a select query where we grab the quote by ID, and we'll do where ID equals question mark. Remember, the question mark is going to be replaced by whatever we pass in this array here with MySQL. So we pass the ID from that params object in the request into the SQL query, into MySQL, so it can just replace it there. If we find one, then great, we'll send it out. If there's a problem, we'll send them a 500 status code. So you can see right here, we're just literally sending the quote out. It's going to be index 0 because there's one element in the array of results that come back. Pretty much every provider for SQL data is going to return an array when you query it. Even if you're returning one thing, it's going to be an array of that one thing, right? So the next one, we have to post a new quote. So remember, the post is to create. So we don't need any variables or any parameters in the route or anything like that. We're just creating a brand new one based off of the JSON you send us. And we're just going to have an insert into, author, and quote. And then we have both of those values in the values segment with question marks. And we pass both the author and the quote right here in this array so that the MySQL query knows to replace those question marks with this data. We run it, everything's good. We'll send back the, looks like just the ID of the inserted quote, which is good practice. Just send back the ID or just enough information that you know what you're looking at. So we want to delete a quote. App.delete path, API quotes, and then we're going to need a parameter for this one because we need to specify what quote to delete. So we'll do an ID parameter. Again, we'll have a SQL query delete from quotes where ID equals question mark. We'll replace the question mark with the ID that's passed in through the request, right? If we delete it, if there's a problem deleting it, we'll send a 500. If we don't delete anything, we'll send a 404 because we didn't find anything to delete. If everything's good, we'll send a 200. We all with me on this so far? Any questions? Anything you need clarified again? I know it's been a few days, so you might have forgotten some details. Lastly, we've got our put. This is our update, so we need to specify what quote we want to update, and we do that with this parameter, the ID. In the update query, we can specify the author equals question mark, quote equals question mark, ID equals question mark. So we've got 3 now. We'll pass them into the array to MySQL in that same order, the author, the quote, and the params, and it will replace the quotes respectively. If everything, something's terrible, we'll send a 500. If we don't find anything to change, we'll send a 404. Everything's good, we'll send a 200. We're on our merry way. We'll slack out the solution, obviously. Any questions on this one? I had to go fast. We don't have a lot of time to dawdle on things that aren't super important today. And since this was a review, I figured it's a little less important to go over. So any questions on this before we move on? Cool. So there's something we're going to start talking about a lot next week. Next week is on Sequelize. And Sequelize is a package you download to help you write SQL queries, basically. And it's something called an ORM, which stands for Object Relational Mapper. So we have MySQL, which is a relational database, right? That is what it is called. That's what that table structure is, foreign keys, primary keys. There's relationships between the tables you define with those keys. It is a relational database. And then we have JavaScript, which we query and we get these objects, right? And we use these objects to execute the queries and stuff like that. But MySQL doesn't have this concept of objects, and JavaScript doesn't have this concept of relationships, right? It doesn't have these. There's a disconnect between the two, and what that causes is some problems. One, you have a lot of queries you got to write, and you got to very manually kind of map how they're supposed to work together. So if you get data back, we're really lucky in JavaScript here. When we get our data back from MySQL, because JavaScript's so flexible, we get back an object that represents the data we would expect from the table. But it only represents the data we would expect from a table row, right? So all of the table row data that you'd get, all those columns, are properties on an object, and for each row that you return or whatever, you would get an object representing that row. And that's good, that's better than nothing. But we don't get a nice kind of hierarchical object that has maybe the relationships. So imagine you have an album in one table and all the songs that belong to that album in another table. In SQL, you might query the album name and all of the individual songs and get a list of 10 different records, right? Because you would get the album and then the song name, and they'd be unique for each record, correct? So we could kind of envision that, these 10 records. In JavaScript, you may not want that kind of structure. You may not want 10 records. You may want one album record with 10 children in an array. Something like that, right? That makes more sense to use in JavaScript. You could send that to the browser with the .json, and you could render that real nice with a header for the album, and then here are the songs. And you can already probably kind of imagine what that could look like. Well, if you wanted to do that traditionally, you would have to get all 10 records, you would have to loop over them, and for every unique header, you'd have to build this object graph, right? An ORM is meant to kind of do that for you. It does two things. One, it does that, so we can take this object structure that we have in JavaScript, we can very nicely represent it and give it to the ORM, and it can do queries for us. Or it can give us our objects in that structure. The other thing it does is write the queries for us. So you have an object of a quote, for instance. Maybe you have a bunch of quotes, and you have one author, and then you have all of their quotes. And some of them are new, some of them are updated, some of them have been deleted, whatever, and you could just give the ORM this author with all the different quotes, and it could update the database for you how it needs to. It could find the existing ones, update them, it can find new ones, add them, and find ones that don't exist in that list and delete them, right? So you have this nice object you can just give to this ORM, and it'll build all these queries, which is really quite nice. Obviously, we've noticed so far that we've been writing very much similar queries for all of these exercises. We could have used the same damn database with just the same data, because frankly they've all had 2-3 columns. I mean, it's been really nothing substantial. And that's irritating, right? You have to write the same thing over and over and over again. If we had no ORM and we could just be like push or add or whatever, and it could just do it for you, all that work is done. And that's what programmers do. They find these problems like this. They say, oh, I've written the same select query slightly differently 50 times. It's super irritating, so I'm just going to write a package that does it for me. Right? And that's kind of what ORMs are intended to solve. They do this mapping between what we expect to see in JavaScript or in C# or in Java or whatever language we're using and what we would expect to see in the database. Solves that disconnect. So what does this look like at a trivial level? Let me pull up some code. So right here, this is a very, very simple example of what an ORM might look like. So if I go to this server, right now what we're doing is we're opening a connection. We have this query with a bunch of question marks in it or whatever, and we're passing an array of data, and it's replacing that for us. But if you had an ORM, and this is a really simple kind of trivial example, but if you had an ORM, maybe you could say, I just want to select and order by an animal name. I'm gonna select the animal name from the pets table and order by price, right? Or maybe you could say I want to select from the pets where the order name equals Rachel, or where the animal name equals Rachel. I'm sorry. Or maybe you could have a query that said I'm gonna select the buyer name and the buyer ID from the buyer's table who has the most pets. Right? And that could build this kind of relationship. Now, this isn't a very great example. For one, these queries, it doesn't give you information about what should be passed where, right? So I'm just guessing that the animal name, pets, and price are in that order. Select the animal name from the pets table, order by the price, because that logically makes sense from a SQL query kind of construction, right? Select from, where, order by, which is probably why they've ordered it that way. That's good. But you can already see that if we have select queries, we're building the select query with just a few characters now, and we can run it over and over and over with different tables by just changing the text, as opposed to writing a whole new select query. So if we look at that ORM implementation, what does it actually look like? Okay, well, we have our select where, and this is a little bit more descriptive now because we can see the variable names, but we can select where our table, right? The column we're going to be conditionally searching with, right? Our where clause, and then by what value, okay? So remember, the double quotes in MySQL takes literal like input. It doesn't sanitize it or anything like that. It's just pretty much straight up, here you go, this is what you get. And the single question mark is supposed to be like a value that you're going to be using. So if you wanted to inject queries, you could do it with this double question mark. So what we're doing is we're injecting the table name, we're injecting where the column we're going to be filtering by, and we're injecting the value that that column should have, right? And so we can, any simple query that just needs a select star from any table, where we're doing a simple where, we can now write with just this function over and over and over again. We can be much more iterative in how we get things done. Now, there's a piece missing to this ORM, and that is the whole mapping part. It's not building a nice object for you, it's just returning the results. And that's arguably a more important piece, to be honest with you. But this is nice anyway, because it abstracts away our query writing, so that's faster. Select in order. Okay, so what to select? These are the columns I want to select. So we could probably even change this to accept an array of columns, or an accept columns that are separated by commas, like you would see in an actual select statement. The table we're selecting from, and then what we are ordering by. So select and order by, right? And you can see how the query has the double quotes, so we can just inject what we want here. And we pass them into the MySQL.query function, and we return the results. Find who has the most. A little bit more complex, but you can see how MySQL can really help you out. Or not MySQL, an ORM can really help you out. We have the columns from table 1. We have, this is a mouthful right here. Okay, so we have the column from table 1 that we're going to select and we're going to get a count of. We have the table, the first table we're selecting from, and then the table we're joining on. And then we have a foreign key specifier. My God. And then we have an order by. This is not a good example. This one is going to be really hard to reason about. But it is an example of something that an ORM could do, right? So we have the buyer name and the buyer ID. We're going to select the buyer name, and we're going to count the buyer IDs. And, oh no, that's not right. We're going to select the buyer name. We're going to count how many times that buyer name shows up. We're joining on the buyer ID between the buyers and the pets table, right? So what we're going to get is the total aggregate of how many pets someone has bought, right? We're going to see how many times someone has bought a pet. We're going to find the people who have bought the most pets. So again, this isn't a super good example because the naming's pretty bad and how they're doing this is pretty bad. You can make it better, obviously, but it still is an example of an ORM abstracting away the query writing for you. The important thing to remember is not how these queries are necessarily implemented, but the fact that they are implemented behind an object, right? Behind something else that executes queries for you, and you as the consumer of the API have very limited work to do to make them work. That's what's really important here. Who cares how they execute queries? I don't personally care. I just care that it can be done faster and easier. So, I ran the schema stuff for this one ahead of time. Oh my God, npm install. Forgot that though. It's easy to forget. Alright, so you can see this is running all three of these queries, and this is what they return. So the first one, select in order, is ordering by price. So if we got, it's only selecting the animal name and the pets. I wonder if we inject. It did not like that. Dang. Oh, it's doing select star. That's why. All right. So you can see that we're running these three queries. So this first one, select in order, select column from whatever table, order by whatever. We are selecting the animal name from pets, ordering by price. Unfortunately, we can't put as many columns as we want in there, and that sucks. We'd have to augment that a bit. But you can see that it's returning the animal name. Is it doing that? Or are they returning in a different order? Because it's very possible that they are returning in a different order. Nope, they're not. Okay, yeah, so this first one is select in order. So it's just returning the animal name and ordering by the price, the most expensive animals in that table, right? And you can see the results here. The second one, it's getting the animal with the name Rachel from the pets table. And the third one, it's getting whoever has the most pets, and that's Jane. Jane has 3. So again, key points with the ORM. We have some form of an object or package or something that can execute queries for us with simple input. Obviously make it better than this because this one's kind of confusing and it's not standard. There's not like a standardized API. You can make it significantly more robust. But this is an example of taking away that individual query writing we have to do every single time, right? So for instance, if we wanted to change this to price, we could get the price of each individual animal ordered by price. So you can see now we have the prices displaying in that first result set, and all it took was me to change that word to price instead of animal name. And that made the difference. Whereas before, I would either have to go change that query or I'd have to write another query or something, right? If I wanted to have both happening, this is where it really becomes powerful. Now I want the animal name one as well, right? Okay, well now I have both. It took that long, as opposed to writing this whole function that you have to call that has the SQL query, right? You can see that there is a massive time savings over the course of your entire project as you use something like an ORM. So technically an ORM is good with productivity and reusability, maintainability. Those things are good. This one, like I said, is a bad example. Terrible naming, terrible API usage. This is not a good example of an ORM, but it is an example of an ORM. Any questions on an ORM, why you would use it, what it does? You don't really need to be an expert yet, because we're going to see a full-fledged ORM that actually does help you be productive next week with Sequelize. That does a lot more cool things than this one does, and does map to full objects, which is really nice. So, any questions? Spend a few minutes looking over activity number 12, looking at this code, talking about it with your partners or whatever, kind of getting a feel for what's going on here. We'll just spend a few minutes, and then we'll move on to the next activity. Alright, has everyone had time to kind of look over this code a little bit? I know it wasn't a ton of time, but we gotta move. Any questions, outstanding questions before we move on? Cool. Well, you're going to try your hand at building one of these. So activity 13, you're going to be given a schema SQL and a seed SQL. You're going to get a couple tables that have structure just like this. And you're basically going to build what we just saw. A few nice ways to quickly execute a bunch of queries. You don't need handlebars or express. You're just going to console log the data. You'll just need the MySQL connection. But you're going to try your hand at building a very, very simple ORM. So go ahead and do that. Well, they're at the beginning of class, yeah. So it's still fun. Give them 2 more weeks. Once we hear them on JavaScript week, then you guys will laugh. Walk over there and see them. They're like,
Start clapping.
yeah,
Oh, is that one of those? Is that one of these boot camps?
yeah. It's like week 2 now. So,
Oh, really?
so you know, it's exciting still. They're not defeated yet.
I think they haven't lost their guns finally. Oh. You can name anything you can.
All right. Let's go ahead and go over this. Did anyone get a couple of queries working? Kind of have a good idea of what's going on? Good. So what are some example things we could do to create this ORM? Well, first of all, we have to create the object that's going to encompass our ORM. So why don't we do that? Nice and simple. Now, here I'm using const. We talked about Monday. You guys were talking about let. These are all variables right here that don't ever change, so we can use this const keyword instead of let, basically. Let and const are more powerful than var. So in the real world, people don't use var anymore. And if they do, they don't know what they're doing. So, simple as that. Okay, so what kind of functions can we build to create this ORM? Let's make sure we're actually exporting our ORM. How about a select from, right? And we can do column, table. So this one's going to be real simple, connection query. It's going to select question mark from question mark. And we'll pass in column and table. And then we'll have our callback. And we'll just make it easy, do a console log. on the data, right? So from here, we have ORM, select from. Let's see what the schema looks like. Let's do client name from clients. Client name, clients. If I go back to unsolved, my ORM got the client names from the clients table. So let's show how awesome an ORM is. We can do that 3 times. If I just look at the schema again, let's do party name and party type from parties. Party name, party type, parties. Run it again. Now we have a whole bunch more data, and it took us almost no time to build those queries, right? So this is a pretty trivial example, but this is kind of how you could get started, right? You build an object, you create your connection, and then that object can effectively take care of delegating the work for the SQL query. So let me show you some of the examples they have. Come on. So we have their version of the ORM. They're actually creating the connection in a different file altogether and just exporting that, which is fine. You can do that. It kind of takes some of the work out of this file, which is nice. It makes this file more limited in scope to doing exactly what it needs to do, which is just create the ORM, right? So they have a select, which just takes a column and a table, right? Just like I did. They have a select where, so we have a table, the column to search, and the value of the column that you could use. So in the server right here, select where, select from the parties where the party type is grown up. Ooh, grown up party. Nice. Let's run it npm install here. And install so I can run these examples. So for the 2 selects, just like mine, the select where, we have the grown-up party, and then they have this left join one, which is a little bit more complex, but shows kind of what you can do. Now this is where making this more robust is nice, where you could have an object you pass in instead of a bunch of parameters, and the object can then have names for its properties. So you could have like join on, and then you could have this array of the fields you're joining on, and then you can have the left table, right table, column name, stuff like that, right? So you can kind of name the properties. I'll show you that in a second what I'm talking about. But this left join, they have what are we going to select, which is going to be this first column, the table 1 and table 2, which are going to be right here. Table 1 is going to go there, table 2 is going to go there, or you could do left table, right table, and then the join key. So table 1's join key, table 2's key right here. So in this case, for what to select, they actually have 2 columns. So you can inject them as an array, and it'll build that column list for you. So that's kind of nice. And that's what they did right here. They have client name and party name, and it brings back both of them. So what do I mean by building an object that's a little bit easier to use? We could change this, wrap it in the curly braces, left, right, left key, so now what I did is I created an object that has properties in it that are a bit more descriptive for the consumer of the API. Is it perfect? No, it's not. But ORMs are notoriously difficult to build well for this exact reason, because they're so flexible, right? From here, our implementation changes to become options. You could do all kinds of validation on your options. Options.left, or you can just trust that it's going to be good, which I don't recommend in the real world. Right? And that should still work, and it does. So what I did here, there's this common belief in programming that if you have a function that takes in more than 3 or 4 different parameters, it's what's called a code smell, because it starts to get hard to manage. So that's when you could use an object to replace that. And what that does, makes the function a little bit more apparent what it's doing, and especially in JavaScript, it's really hard to keep track of what the function's doing because it's dynamic, right? So you can pass in everything. So what I did was created an object here to represent the parameters that would be passed in, and it's easy to extend this object without changing the function signature. You just have to change what's being passed in. And I can give descriptive names or more descriptive names of what's being passed in, right? And then the function just changes slightly by pulling the data from somewhere else. So that was just like a refactoring. From a refactoring point of view, this is how I would probably do it in a more professional implementation. But as far as the important concept of what is an ORM and how can it help you, does that make sense? Are people feeling okay about that? Fist of 5, how are we out today? Okay. So we got Slack this? Yeah, sure. Yeah, sure. I will Slack this out right now, and then we'll move on to the next activity. Unless anyone has any questions.
Seems like the 11 is good.
Yeah, could you guys Slack out the solution to activity 11, please? I will just, do you want me to just Slack out the, well, I'll Slack out both for this one. There's a conflict. So here's the ORM file. And there's the server file.
Are we going to need to build an ORM in our project?
No, you'll use like Sequelize. You don't want to build an ORM. Trust me, you don't. It's a lot of work to do it well and actually make it easier to use than writing the queries. So these are simple examples, right? But if you get into complex queries, it's not simple anymore. And this actually becomes a lot harder than just writing the damn query. As a matter of fact, at work, a lot of times we write the query because a lot of ours are really complicated, and the ORMs they're just as hard as writing the query. So it's like, well, okay. For simple stuff, ORMs are really effective. Sometimes for more complex stuff, though, they lose their their value because the queries are just too complicated, or you lose performance or something, right? So
Are we doing the groups next week?
the groups have already been given out.
No, I'm saying, are we going to start the project next week?
No, next week is another week. Then we start the project. So you're welcome to work with your group now if you want, if they're here.
They're not here. Not there yet. No.
Okay. Any other questions on this? I slacked out those 2 files. Cool. Well, let's talk about the next activity then. Move on. Okay, so one thing we've been showing a lot here that we should touch on, especially with these ORMs and stuff, is asynchronous code. Now, I know we've discussed asynchronous code a fair amount. At least we have an idea of what it is, right? It's code where we can't guess when it's going to complete, so we have to delay that somehow by giving it a callback or using a promise or something, right? We haven't really gotten into promises too much yet, but we've seen them. That .then with jQuery is a promise, and you'll use them a lot more in Node And I think Sequelize will require us to use promises. Inquirer has promises, right? So we've seen them a bit. But either way, the important thing to remember is we have asynchronous code that we can't guarantee when it's going to end, so we need some sort of way to signal when it's over so that we can continue doing whatever we want it to do. Traditionally, with this SQL query stuff, we've been using a callback, just a nice function that takes care of that for you. As a matter of fact, if I clean this up a bit, because this is a big one, we have our function. Right? So this is our callback right here. It's going to be called when our asynchronous code is done executing. Correct? And we're all in agreement on that. Any questions on the asynchronous code, or we know enough about it that we can go, okay, yeah, that's good. Right? Good? Okay. So, my question for you is, in this version right here, and I know it's condensed, so it's a little harder to read, but in this version right here, it takes in the query string, it takes in our MySQL parameters, takes in our callback function, and then at the end, something we haven't done yet, it is returning the result of that query. And out here, where I'm calling select where, I am taking that result and then I'm console logging it. But as you can see from this very clever note, let me install, make sure everything's good. We get undefined. We don't actually get the results of this query. Now, why is that? Does anyone know? Well, let's think about it a bit. We have this callback. This code we already know is asynchronous, and we're using this callback because we cannot guarantee, or we don't know when this call is going to finish, right? We don't know when we're going to get the results back from this query. We can't tell you how long MySQL is going to take, so I have to wait. And by giving the callback, I can wait, and then the callback will be invoked when MySQL is done. Correct? But out here in the server.js file right here, I'm saying as soon as I execute my select where, I want the results. That's not going to wait for anything, is it? It's not going to wait for this callback. That's not how it works. When you have a return like this, it is immediate. So that's the first problem. This is saying, okay, well, you know, I'm going to take a while, so I have to call back. And this is saying, well, give me the results immediately. Well, as you can see from my console, it's actually undefined first and then connected even. It's not even connected by the time I've got this undefined in this variable. Okay, so that's a problem. We're trying to get results immediately for something that's going to happen eventually. Can't do that, doesn't work that way. Defeats the purpose of asynchronous code, right? Might as well just wait for it to be done. Also, the astute of you might have noticed that this return is in another function. It's not even in the main function select where that we're calling. So select where is never actually returning anything, thus we have undefined. So technically that's correct. We are supposed to get undefined because select where doesn't even return anything. And in JavaScript, if you don't return anything, you end up with undefined. So if for some reason I could hook into this function and listen for this when it was done and get the return result, then voila, I happen to have my result. However, there's no way to listen for this function to be done and just accept the return parameter. You can't do it. There's no possible way to do it. Tell me how I could somehow know what this function is, invoke it, or wait for it to be invoked and then immediately get the results. It just is not possible. So your challenge then is to take this and fix it. Make it work. How do you get this result? So you can console log the actual results from the query. So that is the next exercise, and this is activity 14.
So which one do you see feels really kind of
What?
I don't know what you're looking up, but no. It's it.
So we have to pause the result of the coma.
I'm not telling you. This is the exercise. You're supposed to figure this out. I'll tell you in 2 to 3 minutes. Thank you, Alex.
I like how you're asking someone else. What do you think? I thought you were saying it was what it was.
So that was for some specific library, and it's not going to help me now.
I clicked on the first one, but not the same one. No, there's nothing else as soon as it comes up.
How are you doing those things? That's why you're getting nothing. What you should Google is how do I get results from a exit function or something like that.
In JavaScript. Make sure you have JavaScript in there. Did you try it? Did it work? So try it and see if it works. So one thing that could be a stumbling block is if you try to Google something related to an ORM or search for something related to an ORM, you're going to get a lot of bad responses because they will probably be related to some specific ORM package, which we are not using. We are using a hand-rolled pseudo ORM right now, and there's going to be no answers on the internet for how to fix our pseudo or ORM, but there will be answers on the internet for how to get results from asynchronous functions in JavaScript, right? So don't let the ORM fact lead you astray, which it can easily do. We'll give you like another minute and a half or so, and then we'll go over a potential solution. Okay, so Rolando had some ideas of potential solutions to this, which I'll cover after we go over the solution we should be using. And I'll answer why his are good answers, but not quite what we're looking for right now. So, did anyone come up with the solution to this problem? Async call timeout? So, you're on the right track with the whole call timeout issue, because there's something we use with the timeouts that we need to use here. So, to answer the question, when we are calling these asynchronous functions, we use a callback, right? And if we don't know when something's going to finish, we need a callback. So in this case, we don't know when something's going to finish, so what do we need? A callback. So if we just add to the callback chain ourselves, we can solve the problem. So obviously we can't do this. The answer doesn't come immediately. But, whoa, that was off. If we create a callback, and we pass that callback into this function, this one will always fail. We don't need that. Now, we get the results that we expect. So, we already know that callbacks are required for asynchronous calls, but what we didn't realize quite yet was that our ORM select where is part of that asynchronous call chain. So we don't know when this query is going to finish, so we have no idea when we can possibly look at the results. So the only way we can guarantee we'll get the results when they're actually done is providing a callback. So there's a callback provided to the connection query function itself, and then we can pass in another callback to give us data elsewhere, right? So we're just applying our own callback into our ORM to again give us the results when we actually have them. So you can imagine that this callback that we passed in, CB here, is similar to what connection query is doing behind the scenes, right? It's doing some query stuff, and then it calls CB with the results, and then you go ahead and you can use them. So the callback is the answer. We can use callbacks all the way down. Functions are extremely powerful in JavaScript. And you should find every way possible to abuse them because they should be abused and they can be. But it's actually a deviously simple solution, right? You just use a function. Who would have thought? But that's how you do it. I mean, when you think about the callback that we're using to get the actual query results from the connection query function, it's the same thing, right? It's the same thing. We're just now adding another layer. Okay, call back this now. And you could continue to do that if you wanted. We could have another callback inside this callback. It's called back by something else. And sometimes it happens. Let's look at their provided solution. I know they've got one. I want to see what their... Make sure I didn't miss something that they wanted to cover. So... yeah. So here's how they're doing it, which is a little better because they're showing actually the data variable that we wanted to set before. And you can see we're constantly logging that data. Now it'll work. Same thing here. We pass it a callback function. When the query's done and we have the results, we can execute the callback. And in here we can interpret that callback. We can intercept it and do something with the data, right? Any questions on those callbacks? Why we use a callback here? Does that make sense? Why we need this callback? Yeah? Make sense? So, Rolando and Slack brought up some questions. He said, can we use .then? In a way, sure, but not like this. Just because there's a callback doesn't mean .then is available. There's another rule to the implementation that you need to add to this, to add a whole nother layer to it if you want to use .then, and that is you need to wrap this all in a promise. And we don't know how to create promises quite yet, so I'm not going to show it. But if you knew how to do that, you could create a promise instead, and instead of just injecting a callback, your promise could act as the callback intermediary and handle that, and then you'd have access to .then. But we're not there yet. We'll get there later. For now, we just use raw callbacks. Just boom, functions. Here we go. So any questions on these functions, callbacks, how callbacks work, why they're important? Cool. Why don't we take a 15-minute break, come back at 8:20, and we will continue. Yeah. Oh, yeah. It's Halloween, dude. They're out trick-or-treating. They're all like 16, so they still trick-or-treat and stuff.
It's kind of weird because there's like grown-ass men out there too.
They might be trick-or-treating.
Like grown-ass men going up there.
Might be trick-or-treating with their kids.
Yeah.
Damn, gonna go meet up. Show up.
Maybe Monday's their day, you know? Maybe that's the day that they all bro out.
Listen, I requested to have the fifth on. Put in a request to have some epic skis ability.
Okay.
Just so you know.
Yeah.
And then I'll just probably try and
Make sure Stephanie and Chris know.
okay, and then I'll try and rewatch that video because I'm gonna be driving the whole time.
Okay. That is fine.
Super cold outside.
Yeah. Seems to be chilly today.
So I downloaded Minimum and changed my life.
Yeah.
I used to Control C was like killing me.
Yeah. It's real irritating.
This is the guy who really wants to lose his love. That's what it is.
Who's the teacher in the other class?
JJ. It's JJ. JJ might have a sub. I don't know.
Somebody yelled at us. There was no cop doors.
I don't think yell is the right word. Wait a second.
In my heart,
He was yelling.
No, it's after that.
Oh, you totally dodged it? They
I was like head down, and I was just sitting there. So little open door came out. So we were getting big trouble with kids.
Yes. It hasn't even started yet. Protect yourself. I want to be part of this process. This is my first meeting got cast in on the job description.
And bully them out of the
Yeah.
like bully them from something.
No, we're doing the varsity English chapter.
Varsity. Yeah, I don't know varsity, but
Wow.
any public. I am version of you know, Mexicans are very
Just had that excursions.
really? You just had that excursion? Is it Salsa, right?
Was there like only one version there?
No,
You know that one?
no, you mentioned it.
You know, like, when you get to like the version room,
Oh yeah, I think I've worked with it.
like when we went to the version of song into the version room.
Like we're talking like so Springfield right past the road.
Somewhere around there. Yeah. But when I
Main estate.
I know. My cousin and uncle was on the longer that road. So it's up here in Hollywood. Yeah.
They could do anything.
No, it just has a tab on the drive. And then it comes on to that part of it. And then it's like, and here's my paper bag and my phone.
Let's say you're number, but the other head is fucking out of this world with human problems. He takes that little fucking problems and then solves it by sending you email paying off money for it. This is really good.
Let's think that up. There's a plane ticket here. It's sweet. Well, we get it. When we get up there.
It's not that old, it's probably like 57. My mom got it. My wife said no. Two's good. You know, one little fuck up, second one, three won't. All fucking. They don't have a whole lot of substance.
No, anytime you make pancakes, you always drop them.
That is Duran. Duran was actually the instructor when I was a TA the first time through. And so I know Duran pretty well. He's a good guy. He's going to stick to the rules though. So what? He's a jerk? Yeah, he's a nice guy. I like him. Okay, are we all? I guess I'll give you the 30 more seconds until it's actually 8:20. Just in case the streamers are going to the bathroom, or getting a drink, or decided to fall asleep, or whatever. Or actually there. Well, I know Matt's there. He's always usually there, and Rolando seems to be there. The rest of them, it's up in the air, guys. If you don't post anything in the Slack channel right now, I'm just gonna guess you went to sleep. Oh, Charlie's there. Oh, nice, nice. Charlie is here. Rolando's here. We got two.
Kyle's there, but
Not asleep.
They
can hear us, right?
Well, they can hear us. Yeah, this is a pretty good mic. They can hear probably most of the conversation, at least a little bit. Oh, Stephanie's here. That's good.
Oh my God, Stephanie's here.
We got two. We got two. I'll give you 10 more seconds before I count you out. Oh man, there's a lot going on right now. So the fact that no one else has chimed in is leading me to believe Garrett's here. That's good. All right. Okay. So let's take some time to look at activity 15, which is a review of callbacks. We'll just kind of walk through it together.
Exactly what I was doing.
I don't know why we have some jQuery here. But, callbacks. We'll start from the beginning, I guess, with this callback review. So, like we were talking about with the query, like we were talking about with... Oh, Mike's here. Nice. He caught us right at the end. Alright, so like we were talking about with the query, the connection.query, like we're talking about with our own callback, we pass into a function. Like we've seen with jQuery before, callbacks come in all shapes and sizes and forms, and they're very important for anything where we don't know when it's actually going to happen. For instance, if we remember jQuery, our on-click handlers, do we ever know exactly the moment a user will click the button, a button? No, we have no idea, right? Because it just sits on the page, and they click it when they feel like it, and half the times they don't click it at all. They just leave your page right away, and then you feel bad because your bounce rate's really high, right? But, you know, we can't do anything about that. However, the callback is there because when they do click the button, we want to do something, right? And so that function is basically a value passed into the onClick function that is then going to be executed later. So again, if we do like our rough implementation, you can imagine that jQuery has some function on, right? They create some new event or something, and then you can imagine if event.handler equals handler, then it'll call the callback or something. You can imagine it looks something like this. This is obviously not what it looks like, but it's like our rough guess of what's going on. Where some event is manifested from the browser and given to jQuery, and the jQuery is like, okay, cool, well, this is click. Was this event a click event? Oh, it was a click event? In that case, I'm going to call my click callback. And then we get alert boom. Make sense? Fist of 5 on that one. There's not that many of you, so you all got to put your fists up. Okay? Alright, so, was that a 0?
That was my fist.
Oh, okay. Fair enough. You did put your fist up. Alright, so this is a simple callback that we've seen with jQuery time and time again. We know at this point how they work, kind of. We know that they work, but we don't necessarily know how they're implemented. Now that's okay. You don't need to know how jQuery does it specifically, but you should understand what a callback is and how it's used. So, this one's a little bit more complex. We have two functions, sum and a multiply. Sum takes in a number 1 and number 2 and adds them together, as a sum function does, right? Multiply takes in number 1 and number 2 and multiplies them together, as multiplication works. And then we have these add callbacks, where it's going to take a first function and a second function, and it's going to add the result of both of those. So what it's doing is taking in these individual functions, it's running them with these numbers, and then adding those results. So what's the answer going to be? Well, function 1 is multiply, so 6 times 2 is 12. Function 2 is sum, so that's going to be 9. 6 plus 3 is 9, so 12 plus 9 is going to be 21, right? That's what we're going to get. The math isn't that important. What's important is we know that these are functions being passed into another function that is then executing them at a later time. It's immediate in this case. There's no async. But either way, these functions that are passed in here are not executed immediately when this function's called. They're executed inside that function. I know there's a lot going on there. It's very abstract, but hopefully one day this will really sink in, right? So this example, is it confusing anyone? Is it hard to reason about? What are we struggling with right now, if anything? Everyone's good? They could, if I said I need a function that takes in a callback and executes something, we could write that right now? Okay, taking your word for it. So let's look at another exercise. This is... Okay, so, Nor, why don't you tell me what this is going to result in?
0 and then 6.
0 and then 6. Well, how did you get that?
6 minus 6. That's the first one to subtract.
For subtract 6 minus 6. So function, look at the line 14. So if you look at the definition on line 9, add callbacks is a function that takes in function 1 and function 2. If you look at 14 where it's calling add callbacks, the first function is subtract.
4.
So, okay, we have 4 plus function 2 is multiply.
So 9. Oh, it's times 3 is 18.
18, so 4 plus 18. So 22, right?
Right.
Alright. Next example, we have sum and subtract. Let's see. Jaime, what is this going to equal? 13. How?
Because it's going to take in function 1, which is 6 and 2, and the subtract function, which
Okay.
is 4.
Okay.
And then function 2 is going to throw in 6 and 3 and sum those out.
Exactly. So, for those on the stream who might not have been able to hear, the function 1 is going to be the subtract function, as we can see on line 14. And it's going to subtract 6 and 2, make 4. Function 2 is going to be the sum function. It's going to add 6 and 3 and make 9, and then we have 13. All right, Peyton, what do we got for this example?
For
Number
number 5.
5.
Let's see. So you're add callbacks, you're passing in sum, and then subtract.
Mm-hmm.
So function 1 would be summing that, so that'd be 8 plus function 2 would be subtracting that, which is 3. So 12 or 11.
Yeah, 8 plus 3 is 11.
Yep.
Right. Yep, nice. Okay, ooh, this one is about to get wild. Garrett, what are we doing here? So, let's just start with the first function, go to the second, then let's go to the third, okay? So function 1 right here is what? Multiply. So we're going to multiply 3 times 4, right? Which gives us 12, not 23. Function 2 is subtract. So we're going to subtract 7 and 2, which gives us 5. Function 3 is sum. So we are going to sum 12 and 5, which gives us 17. So that's how you should visualize it when you're doing this in your head, because it's really hard to kind of track everything that's going on. Try to evaluate the functions one at a time. Now, this isn't always possible. Sometimes you'll get functions that are just insane, right? And they do a bunch of stuff, so you can't actually evaluate them. But in this case, it shows a very complex kind of nested structure of functions, and you want to evaluate them one at a time, almost like order of operations. It's not quite that, right? Because technically there are different rules. You would multiply, then you do whatever's in the parentheses or whatever. And this one kind of follows suit because we multiply first, then we're going to subtract, and then we're going to add them together. But it's not totally following order of operations. Try to evaluate the functions one at a time. And if you have to do a substitution like that, okay, well, this takes in multiply, and this is going to be multiply, and kind of follow in your head, that's fine. That's totally fine to do until you really can reason about what's actually happening. Because being able to just track this, quickly look at it and understand it takes a while. It takes a long time to really understand what's going on here because there's a lot of functions. And at first looking at it, it's a big block of just parentheses and words and just garbage. It's really kind of hard to understand. So try your best to like evaluate one at a time and kind of move out of the functions, right? Because they're nested. So you start in the center and you move out. Yeah.
The difference between 6 and 7 I see is like return. The rest is the same. It doesn't say return before the function. It's the only thing that you could do between 6
Yeah, so this one won't console log anything. If you're looking for a value, it would be undefined, but it's going to add up to 17. We'll just have an unknown 17. So, yeah, it's undefined if you were going to console log, but because there's no console log here, it's undefined anyway. Yeah, because there's no return. If there was a return, we'd be returning 17. And right here, so nice sketch, Andy. In that case, it would be 17. And if we were to try to get the result right here, the result would be undefined. But because they're not console logging anything, that's kind of a trick question, so I don't count that. What's more important is...
They were trying to get you on the lock note. That's what that was.
Yeah.
Lock note.
Yeah. So 7 now has that return, so technically it would equal something if you were to grab the result out. I don't know if that distinction makes sense. I think the question they were trying to ask was lost in the fact that there's no console logs or anything. They're just like, well, there's still a value. There's still 17. It's just not being used anywhere, right? So that was kind of poor craftsmanship on their part. Okay, so this last one, let's see. Adam, you want to do it?
17.
This one going to be 17?
3 multiplied 4 is 12, 7 minus 2 is 5, 12 plus 5.
Oh, damn, it's the same numbers, yeah. I didn't even notice that. You're correct. It is 17. Good job. Yeah. Alright. Callbacks. How are we feeling on the callbacks? You feeling okay now? We kind of got a better understanding. I know it shouldn't be perfect, but... Okay. Well then, if no one has any questions, we'll go ahead and move on. We're actually making... Okay. No, there's still a lot left. Never mind. I was going to say, we're making good time, but there's a ton left, so we're not really... Kind of, I don't know, 20 minutes, 40 minutes... There's only an hour content left, so... Wait, no, oh, nope. No, I don't know, I can't count, so... There's a lot left. We'll finish it, though. Okay, so we'll be quick on some of these. What? Oh, keep making you so excited we'll get out early and then go, oh, never mind. Yeah. Okay, so we are going to talk about another pattern here. We're going to kind of stray away from the ORM and we're going to talk about an architectural pattern. So the ORM is a kind of a design for, okay, it didn't like whatever I just did. It's kind of a design for making code more reusable or maintainable depending on how you build it, right? But it's not really an architectural pattern. You don't think about an ORM and the overall architecture of what you're building. You may realize, hey, I need an ORM to help me do stuff, but in terms of how am I actually going to organize my project so that it's easy to use, an ORM doesn't fit in that category. Instead, when we're thinking about these web projects, there are well-defined patterns for how we should architect things. And one of them is pretty well known, is called MVC. M as in model, view as in view, and C as in controller. We've done this effectively already, we just haven't formalized it. So what does MVC look like? Well, let's start with the V, view, model view controller. View is the easy part. View is your display, effectively, right? In this case, it's handlebars. The view traditionally doesn't have a lot of logic, if any at all. We try to keep it all out of the view, so your view doesn't become a point of lots of changes and lots of complex logic, right? That should be handled elsewhere. But your view is essentially where you'll display your data. So, you know, we have handlebars. We can use the templating stuff to kind of take our data and display it on the page dynamically and do all that fun stuff, right? So we've seen the view plenty of times already, even if we haven't formalized its name. It is called views in Express, which is convenient, right? Because Express follows this MVC pattern. So M, models. What's a model then? Well, a model should represent your data. Now, this is kind of a weird model. I don't necessarily agree with it, but it is a take on a model. In my opinion, a model is basically the thing that holds your data that you're going to supply to the view. So you have this model, say you're querying the database, and this kind of does it. Say you're querying the database and you have a cat, right? And a cat has a name and a fur color and an age and a weight. You can imagine that you have all of those properties on the cat, right? Name, age, 0, weight, 0, color. You could imagine that they're like they're empty or something, and or you just have this cat object, and then you can query the database. This one is weird. I'll kind of use this example, but in this case, the model doesn't have those properties necessarily, but it allows you to get those properties. So the model is kind of representing your ORM, where it's going to be used to gather the data, right? So I have data. I have stuff related to cats, and I want to get information about these cats so that I can display them in my view. The model is the one that's going to be in charge of delegating information to the view. So it's going to be in charge of holding the information, potentially getting the information for the view, but it's not actually going to be in charge of matching that information with the view. Okay? So it's going to hold information and be kind of a data carrier, but it's not going to be the one that takes that particular model and puts it with this particular view. That's the controller. So the final piece to this is the controller, and what is that? That is like our routers that we've been using in Express so far. We've just been using the app.get, app.post, app.whatever. So the app is effectively our controller, but those individual routes are the controller functions that do the mapping between the model and the view. Okay? So for instance, we have this cat. It's going to, in my opinion, the cat, let's find the get. The cat all is going to return all of the cat models. The cat all isn't necessarily the model. It's an ORM. It's an intermediary piece. But it's going to return the cat models, which would be the data from the query, right? So we get all these cats back here in this callback. You can imagine these are just cats, right? And the controller's job is to call that query, get the cats from the ORM, and supply those cats to the appropriate view. So the controller is going to have information about the route you're in. It's going to have information about where the user wants to go, per se. And it's also going to know what view it needs to use and what models it needs to use. And it smashes them together. So your controller is really the key piece that's in charge of doing all the work, right? Your model is in charge of managing data. Your view is in charge of displaying data. Your controller brings it all together. And that's effectively the premise of MVC. There's not much more to it than that, to be completely honest.
So you always have to make sure all three of those are employed synchronized for them to show up.
Yeah, so the model,
You can't have one missing.
I mean, no, you'll always have them in some form. Even if you don't necessarily organize them this way, you'll have them in some form. So it's just kind of more of a natural way to explain this ordering that we have, okay? Well, we have some form of a view. You know, the user's got to see the data somehow. And we have some form of a model because we have data, right? And then we have something that delegates the two and puts them together and kind of does all that work. We'll call that the controller. So you always have all of those parts. There's just not been a formal name until really now. Now, MVC specifically is used a lot in web development because we think of our views as our HTML. We think of our models as the data that's coming up from the database, and our controllers are our routes, right? They're our routers. And actually in some languages, like C#, for example, the routers are called controllers. The models are called models, and the views are called views. So, literally MVC. There's actually a framework, ASP.NET MVC. So, MVC is pretty ubiquitous. It's not just a JavaScript thing. It's not just a... it's like more a base web development architecture thing. Okay? So let's see if there are any other points that I was supposed to bring up. I don't really know. What I think you should do is take this code. It's number 16. open it up, kind of look at how they're breaking things down. Now, one thing that we haven't seen is this Express router. So in Express, you can actually create a router. What a router does is it allows you to call get, put, post, delete, all of those functions. You can imagine this router is synonymous with app. So if you just change this to app, it would work very similarly. The only difference is you can export the router, and in the server, instead of adding the app everywhere, we can literally take the router and just use the router, right? App.use the router. And what happens is, instead of having app.get, app.post, app.put, app.delete, we put it in this router, we do it in its own file, and then you just call the router into app.use like it's a middleware, like any of the other middlewares, and it'll use those appropriately. So it's a way to kind of break up those controllers or those routes into different files, right? So it's just a nice organizational technique. Do you need it? Not necessarily. What's funny?
Just sort of very confusing. Can you do that again, starting at express.router?
Yes. So we want to create a router. How would we create routes now? We would have app, right? And we do app.get, app.post, app.delete, all that fun stuff. So imagine instead of router, we add app. And just ignore this. Pretend it's not there. This looks familiar, right? We're all used to this now. Here's the difference. Let's rename this to router. All our routes are the same. They work exactly how they would work if you added them to the app. Nothing has changed yet, okay? But we have this router object, and we have to somehow tell the app to use it. So we're going to export it. Don't get too confused by the export. We're just exporting the router itself. And then here in the server, instead of adding all those routes directly to the app, we're just saying use those routes. And it's kind of like another way that you can set up all your routes, as opposed to just putting them directly on the app. So just like we have middleware for getting static files, just like we have middleware for getting JSON, parsing JSON, we have this middleware for our routes now that literally does that work. Does that make more sense? A little bit. Getting closer? Does that make sense over here? So inspect this code, try to figure out exactly what's going on, try to run this code, and see if you can't make more sense of it. Spend a little bit of time just kind of playing with this MVC architecture.
So they're always going to be like MVC architecture, like website.
For us here, yes. Until we get to React, then it's not anymore. But
So he's saying it's easier to do that.
no. I'm just saying this architecture changes. There is one thing that I didn't talk about that I do want to touch on. In our handlebars views, there's another one of these commands we can use, right? So we have the this each command or each declaration, whatever you want to call it, that allows us to loop through an array, right? We have an array, we say each, and inside of that each block, we can do whatever we want with each one of those cats in this example. Well, there's some other commands like that, and you can actually define your own, but a simple one is if. It's an if statement. That's all this one is. If sleepy, then you can do some stuff, right? I honestly have no idea what the hell this is doing. What?
Was like sorting it?
It's pretty kind of stuff. Yeah, cat.
Anyway, the if right here, sleepy, that's a Boolean, right? That's going to evaluate. That's going to be true. And then we're going to run this expression in here if that's true, right? So if it's true, then we can do whatever the hell this is. Oh, here you go. It's a partial. Cat block. Great. So there's a lot in here. So if it's sleepy, we're going to render this cat block, this partial cat block, with sleep set to false. And then in here you can say another if sleep is true, then sleep time, else wake up. Okay, so you can imagine if sleepy, then we're going to execute this code right here. Right? If sleepy, we're going to do this. Now there's another one unless. That's the opposite of if. If this is false. If sleepy is false, then we're going to set, well, that seems backwards. That's how it works, though. If sleepy is false, then we're going to go ahead and run this code again. But this time, since we're setting sleep to true, it's going to say sleep time. Right? So that's what's happening with this little render here. It renders as partial. So it's looking in the cats folder under partials, and it's looking for the cat block partial, and rendering it with that parameter sleep set to false or true. Yes, that must be the specifier for a partial. If we look in our server.js, we should be able to see, it must just know to look in the partials. So when you have this caret here, this angle bracket, it's like, okay, well now we need to go look in a partial. So this is totally new syntax.
Partials has to be in views.
Partials has to be under views, partials. So you have, remember how we have layouts for like our main layout? We specify which layout we want to use. Partials is the same. It's going to be a special folder called partials, and under there you can define whatever you want. In this case, it's nested under cats folder, the cat block handlebars, and this is a variable we're passing into it. So you can pass in variables, probably as many as you want. Interestingly enough, that is not even in the lesson plan. So this is extra code that we get to look at together and figure out right now. Which Justin apparently knew about, was trying to tell me, and I was like, I don't know what you're saying to me, Justin. Yeah, it makes a little bit of sense once you break it down, but I think also it doesn't make sense because if sleepy set to true, then we're going to not sleep, and if we're not sleepy, we are going to sleep, so they messed that up. Because unless is the exact opposite of if. That block will run if the expression given is false. So if the cat is not sleepy, then we're gonna set sleep. We're gonna tell it to sleep. It doesn't even make any sense, right? So this is a horrible example with stuff that's not even in the lesson plan. So Trilogy, if you're listening, shame on you. But we figured it out. We figured it out. All right. I know that was a lot. That was very confusing, I'm sure, because we backtracked a little bit and it wasn't so obvious what was going on for any of us. Try to take some time to look at this code and figure out what it's doing before we move on to the next activity. This is 17. Or no, this is 16 you can look at. And then we'll go into 17. If you want to start it, go nuts. But I wanted you to take some time to look at this code first. Try to digest what's going on because there's a lot. There's definitely a lot here. This is a good example for a lot of things because partials are really powerful. It's just another feature of handlebars that we can take advantage of. And like I said, if you were to do a website like this traditional MVC website, Handlebar's probably the best templating engine you can get. So it's a good engine. I really think it is. So when you feel comfortable with this code or you feel ready to move on, you're going to get a lot of this code in Activity 17. Move on to Activity 17. What you have to do is take this code effectively, and you have to add a delete function to the controller and a delete button on the screen on the view so you can delete the cats. So you're going to have to get this running. You're going to have to run the code to get it into MySQL. You're going to have to do all of that rigmarole to get this thing up and going. And then you can edit it to get the delete button in there and go from there. So that's what we're going to do for pretty much the remainder of class, and then we'll do our checkpoint. And then we'll go over the homework first, then we'll do the checkpoint. So we'll slack out the solution to this one, but we're not actually going to have time to go over it. So work, and then Chris at 9:15. You can come up and go over the homework, and then we can slack out the checkpoint. This is 17. You want to do 17? My bad.
believe in medical.
Yeah,
Great
like
call.
rubber dubbing.
Yeah, that remember.
They probably think the last one just changed.
Don't touch the road.
I'll see if the game is
Well,
going great.
Find out. You have to save it. Essentially just turn around.
Yeah, you should mark it. You gotta mark where it's goes at.
So what's that?
So yeah, so the real right here. Yeah, yeah. He's right there. Yeah, he's pointed right to it. He's gonna think that they'll tell Jason, you know.
Here, I'll put it at a not so obvious and it's right at the end. I'll put it like in a random spot.
Oh wait, don't you want to turn it up first?
Yeah, I mean, it's already here. But I don't want to be so obvious that I like it. Really set it all over.
Yeah.
Well, maybe I'll turn it all over. Now actually, yeah.
Oh, you read the hints?
I was just I'm too. I was when I first got here. This is all the way down. It gets colder. It would get colder when it was still hot out. So it seems to turn up. On Sunday or Saturday. I will be here this Saturday, so unfortunately for you guys, you have to deal with me.
It's okay. I hope the hints didn't. No. The hardest part is for where is it at in the
It's in the same index document page.
but I got it.
Yeah.
You guys submit under partials from the camera. Under feelings. Oh, you need to post that with it. I just copied it from the site and I did it.
But you'll learn about password if you don't already know it.
Yeah, I don't know it. I mean, I was just reading through the docs and it seems really, really simple. I just don't know if you use your own database or you use Password database.
You can hook it into yours. So there's like there'll be like a plugin for Mongo or whatever if you need to use it. Yeah. Or you would they have like a callback or something for login. You would just read from your database then with the password, username, password, and verify that the person exists.
Yeah, I use it every 2 weeks. It's not much. It's like a design. It'd be one thing if they just never came in. Like, we just had to know to do it from the beginning, it'd be fine, but
Started.
like, they started doing it and came out.
All right. We're just gonna have Stephanie slack out the solution so you can look at it later tonight if you'd like, since we've got to finish up the last couple things. So Chris is gonna come go over your homework, and then we're gonna slack out the link for the next checkpoint. Just so you remember, we don't grade the checkpoints; they're just for you, so Trilogy can know kind of where you guys are at this point in the course and self-regulate that way. So take it best you can. Once you're done with that, you can get or you can stay, and we'll go over the answers. So, kind of up to you. So anyway, let's let him go over the homework, and then we'll do the checkpoint.
Alright guys, we're going to make this pretty quick. So this homework is Node Express handlebars. On this assignment, you'll create a burger logger with MySQL, Node Express handlebars, and a homemade ROM. Be sure to follow the MVC design pattern. Use Node and MySQL to query and route data in your app, and handlebars to generate your HTML. When trying to connect remotely to your Heroku database on an open network such as Coffee Shop Library or whatever, it will be blocked. If you're experiencing a Heroku connection error, this could be why. I don't really know what this is, but I'm assuming it's probably the MySQL Heroku deployment guide.
I slacked that out. That's in Slack.
Okay, perfect. So before you begin, Eat the Burger is a restaurant app that lets users input the names of burgers they'd like to eat. Whenever a user submits a burger's name, your app will display the burger on the left side of the page, waiting to be devoured. Each burger in the waiting area also has a Devour It button. When the user clicks it, the burger will move to the right side of the page. Your app will store every burger in a database, whether devoured or not. Check out this video right here. We're not going to show it in class, but if you want to know what a running application should look like, that video is right there. Submit it on BCS, and the instructions, we're not going to go over those, but definitely with the instructions, read them step by step. Go through the whole entire document. If you get confused on something, go back and read the document, or read the instructions again. It's going to go through app setup, DB setup, config setup, model setup, controller setup, view setup, directory structure, reminder submission on BCS, minimum requirements, and then this little section about hosting on Heroku, creating a README, add to your portfolio, one more thing. This is a really tough homework assignment, but we want you to put in your best effort to finish it. If you have any questions about this project, please post them in the community channels so that your fellow developers can help you. If you're still having trouble, come to office hours. So with this assignment, I mean, it's really big. This is pretty much everything that you've been doing up to this point. I would say not to, unless you're really good and you get everything done and you feel like you're ahead of the game, then work on your README, do a really good README. Now, if you get this whole project done, it's going to be something that is going to look really great on your GitHub and in your portfolio and stuff like that. So I would, if you get it done, do the README, but I wouldn't focus too much on the README or any of the like extraneous things. So just try to get a minimal application running. Let me go ahead and slack out the link for the checkpoint, and then we'll go from there.
The spec order made this like assignments as if we're
I like food, but I don't particularly care for cats. They're okay. They're like crappy dogs.
I don't even have a pet.
Alright, since we're just doing the checkpoint for the last part of class, I'm turning off the stream now.